Right, I hope everyone has read the questions. I will start doing it. A mass of 500 kg is to be maintained in a position by pulling a rope taken over half barrel. Okay, so half barrel in the sense here it's like what is that? It's like a spear or something where over this barrel, okay, over this barrel, the wire has been wounded. Okay, you could see that the wire has been wounded over it, and then it is taken, and then it is twisted over capstan. Okay, so and how many times I'm twisting it, that is how many times I'm wrapping it twice. Okay, I'm wrapping it twice. Okay, if the coefficient of static friction is 0.2 for all contact surfaces, so which means any surface you take, the coefficient is 0.2, which means this surface is also going to have a coefficient 0.2. This surface is also going to have a coefficient of friction 0.2. Okay, that barrel is also going to have some coefficient. This is also going to have some coefficient. Calculate the minimum force F. Okay, calculate the minimum force F required to um, maintain the load. Okay, just a moment. Yeah, so here what basically we need to do, this is a very good question. Okay, other than whatever they asked in the question, I need many other things also to explain. Okay, so you will learn many things from this one question itself. Okay, so from this one question itself you will able to answer many other questions also. Okay, right, listen. Ultimately, just imagine the situation. You are not applying this force. Okay, if this force is not applied, what will happen? This load will be moving down, right? That is very common. That's what going to happen. Okay, this load is going to move down. I'm applying, what are the different conditions? What are the different conditions? I might apply a force which is not going to be sufficient. Since if the force is not sufficient, this load might move down. Okay, that is one case. The load will be moving down. Second case is this force F is just sufficient. Okay, it is just sufficient so that this load will not move down. It will just stay, which means if I just decrease this force, for I will just give an example. Okay, let us consider that F is equal to some value F. Okay, for this value F, there is no problem at all. The load the that load is going to move down happily, or else I don't want to take small f. It will confuse. I will take it as some P. Okay, for this load P, the load is going to, that is for this applied force P, the load is going to happily move down because it is not sufficient. Okay, the force is not sufficient to hold the load. Okay, now I'm applying load Q, which is just sufficient, which means with the help of this Q, I won't able to lift this load. Okay, I won't able to lift it, but I will able to avoid this load moving down. Okay, I will able to avoid this load moving down, so there won't be any motion. That is, it's not allowing the load to move down. Also, this force is not sufficient for lifting up. Okay, so this is the load which is something like at the verge of motion. Okay, at the verge of motion. Okay, now after this force, any force which is going to be greater than Q. Okay, you take any force which is going to be greater than Q, then this load is going to move up. Okay, this load is going to move up. Okay, this load is going to move down. This load, that is, if F is greater than Q, then the load is going to move up. So there will be motion. Okay, there will be motion in such that the load will be moving up. Okay, so ultimately, what is the question here? The question is, calculate the minimum force F required to maintain the load. So they are asking us to find out this condition. Okay, they are asking us to find out this condition. Okay, what is the force F I need to apply so that this load will be maintained at the position, which means in other word I can say it is at the verge of motion. Okay, if the load, that is, if this force is less than Q, then it will start moving down. If it is greater than Q, it will start moving up. Okay, so if it is going to be less than Q, then it will start moving down. Greater than Q, it will be start moving up. So it is at the verge of motion. Okay, so this is what the question they are asking. Okay, let us do one thing. Okay, let me draw free body diagram for each and everything. I will draw free body diagram for this one and also for this one. Okay, I hope the hemisphere was there. If hemisphere is not there, okay, semicircle is there, that will be enough. but it's that. Okay, just imagine that it is what is that? It's a semicircle. Okay, it's a semicircle. Yeah, it's a semicircle. It's a semicircle, which means, sir, can you please explain again the three cases? Okay, okay, I will come back for it. Just a moment. I'll come back for it. Okay, so this is the half barrel, which I'm taking it as one. Anyway, I will explain it anyways. You don't have to worry. This is the half barrel which we taken. Okay, okay. So here the wire, or what is that, rope, okay, rope is wrapped over only some part of the half barrel. Okay, so from this top position until here only the wire is, that is the rope is wrapped. Okay, not over the complete, not over the complete sphere, not over the complete sphere, only over this end only the wire is wrapped. Okay, and from here, that is if I'm drawing free body diagram for this, right? So I'm cutting it here and I'm cutting it here. So what will happen, this will have some tension. Okay, this rope in this end is going to have some tension. T, let it be T, and this end is going to have some tension. Okay, this end is going to have some tension, or else I will first take this as T. Some tension is going to be there. Okay, some tension is going to be there. Some tension is going to be there here, and some tension is going to be there here also. Okay, and how much is this tension is going to be? This tension is going to be that load itself, which is M into G, which is nothing but 500 kg. 500 kg means 500 into 10, 500 into, that is 500 into G, 500 into 10, so 5000 Newton. Okay, so this tension is going to be 5000 Newton. Now the question is, it is falling under which case? It is falling under the case where it's something like a pulley, right? Half barrel means it is something like a pulley with a wrap angle. How much is the wrap angle? How much is the wrap? I'm sorry. Okay, no problem. Yeah. How much is the wrap angle from the top point? Okay, and also from here. Okay, so the wrap angle is 90 degree. So theta is 90 degree, but we already know that theta should be taken as in radian only, which is pi by 2. We know the formula also. What is the formula? T1 by T2 is equal to e to the power of mu theta, right? E to the power of mu theta. Mu is known, theta is known. Okay, both mu and theta is known, no problem. But the problem with this question is, what is my tight side and what is my slack side? Tight side means tension T1 has to be greater than T2, okay, which is my tight side, and which is my slack side. Again, finding out tight side and slack side in this particular question is bit trickier. Okay, it is bit trickier, and that depends on these cases. That depends on these three cases. What is our question? Our question, they are asking us to find this. Okay, suppose if it get changed to the case 3. Okay, I will be doing both the cases anyways. I will be doing both the cases because just to show you how it differs. But first I will do the what they are asking in our question. Okay, right. So it depends on this 3 case. Based on this 3 case only, I need to decide which one is T1 and which one is T2. Let me explain the case again, as Gopi has asked me. So I will explain that cases again, and then we will continue with this. Okay, right. See, what is actually happening? I need to apply some force. Okay, I need to apply some force such that I need to maintain the load. The question they given was, I need to maintain the load at the same position, whichever it is there. If suppose, just consider a situation where I'm not applying a force at all. Okay, there is no force applied, or I'm applying very less force. Okay, or I'm applying very less force. If that is the case, automatically this force, okay, that is our first case, automatically this force F is not going to be sufficient to hold this body at the same place. So this body is going to move down. Okay, that is our first case. Now, second case is, I'm applying a force which is equal to Q. Okay, I'm applying a force which is equal to Q such that I am holding it at the same position itself. Okay, this body is not moving up, this body is not moving down, it is exactly at this position itself. Okay, so the point at which, or the force at which I'm maintaining this. Okay, the point at which, or the force at which I'm maintaining this is F is equal to Q. So it is not, there is no motion below, or there is no motion above also. But if I increase the force more than Q, okay, little more than Q, even if suppose if it is 100 Newton, but if I increase it to 101 Newton, that is the applied force. Okay, if the applied force is increased to 101 Newton, then also this load will be moving down. or else if it is 100 Newton and if I decrease it to 99, it will start moving down. Okay, so simply this is the force. Okay, this is the force at which the body will be in static equilibrium, or I could say that it is at the verge of motion. If I decrease it a little, this load will move down. If I increase it a little, then this load will be moving up, because this force is sufficient for pulling this load up. Okay, I hope you got the point, right? Three different cases. In our question, they are asking us to find out. Yeah. So in our question, they are asking us to find out the minimum force F required to maintain the load, which means I need to just maintain at this position itself. It should not move down. Okay, it should not move down. I need to avoid moving it down. Okay. And what is the minimum force they are asking? Okay, minimum force means obviously at the verge of motion, because when it goes above Q, okay, when it goes above Q, then automatically it's going to move up. Okay. So I hope you got it. Let me just go with the case 2, that is this case. That's what our question is. Now, see, finding out tension, that is which tension is our slack side, that is which tension is going to be tighter side, and which tension is going to be a slacker side. That is challenging task, as I said already. I will say it's a very simple one, but it's a very simple one conceptually. One thing you need to understand, this load is fixed, right? I'm not going to change this load. Okay, I'm not going to change this load at all. I'm not going to change this load, right? And if let us consider that this barrel is not there. Okay, this force is not there. This load will happily move down. Okay, if this barrel is not there, if this if I'm not applying any force, this load will happily move down. But what are all the things which is resisting this load? If you focus, what are all the things which is resisting this load in moving down? You might say that, sir, this force, right? F is the force which is resisting the load to move down. See, just imagine a situation. 500 Newton load. Okay, 500 Newton load. If I want to keep this 500 Newton load at the same position, I need to apply 500 Newton. Then only it will be in static equilibrium. Logically, just think logically, I need to apply 500 Newton. But what I am doing here, I am taking help from friction. Friction here in the half barrel, and also I am twisting it over the capstan, right? So here also there is going to be friction. Okay, here also there is going to be friction. So I am taking help from friction, not only the applied force. See, if I directly try to hold that load, okay, if I directly try to hold that load which is weighting 500 Newton, I need to apply 500 Newton. No doubt about it. I need to apply 500 Newton in upward direction to maintain this load in the same position. But here, what I'm doing, I'm maintaining this load. That is, I'm maintaining a load of 500 kg. I'm sorry, 500 kg with the help of friction provided in this half barrel and also friction provided in this capstan. Okay, so ultimately the force, the force which is required will be surely less than that of the load. See, this is one small point you need to understand. Okay, if you understand this, then the problem is solved. Okay, so what actually I need to do, I need to hold this load. If I want to hold this load in general, if I want to hold it, I need to apply 500 kg, right? Sorry, I need to apply 500 kg, no doubt about it. But here I'm taking some help. What are the help? Friction which is acting here. Okay, this friction is also going to help me. Okay, this friction is going to help me in holding this load. And also this friction is also going to help me in holding this load. Okay, so ultimately here I have a string, right? Here I have a rope. So this rope, there is going to be some tension. This rope, there is going to be some tension. This tension, okay, this tension surely has to be less than that of the applied load. Just this is the only critical point. Okay, this tension, I will just write it as tension. This tension surely has to be less than that of applied load. See, if it is greater than applied load, then what is the use? What is the use in using the friction? Okay, what is the use in getting help from friction? Okay, if I want to apply 500 kg for holding 500 kg load, then why I need friction? Here friction is helping in holding this load. So this tension which is present here in this rope, okay, in this rope will be surely less than the load. Now further what is happening? I am again twisting it over the capstan. Okay, So here also there is going to be some friction. Here also there is going to be some friction, and this friction is also going to support loading, that is support holding that load. So that force F will be further less than that of tension T. Okay, so I will do one thing. I will take it like this. Okay, I will write it down here so that you can understand it clearly. I will take this tension to be T2, tension in the horizontal string, okay, to be T2, and tension in this vertical string to be T1. So T2 should be surely less than that of T1, okay, and if you consider F, it is further less than that of T2, okay. This is the condition. So surely this tension is going to be T2, that is smaller, and this is T1, which is going to be greater. Any doubts? Tension, which tension? Actually this T2 and T1. Exactly which point? The point which I said now. Okay, see, that is what I'm repeatedly saying, right? That is, this body is having a weight of 500 kg. If I want to hold that weight 500 kg, then I need to apply 500 kg. That is 500 kg of load has to be applied. But here this friction is helping us. Okay, the friction which is present between half barrel and the rope is helping us. Because of the friction which is helping us, the tension which I need to apply here, okay, the tension which I need to apply here so that I can pull it, okay, so that I can pull it, or not pull it, so that I can hold it. I'm not pulling it, okay. I was in the second case only. Third case I will explain it later, okay. I was in the second case only. I'm not pulling it, I'm just holding it, okay. If I want to hold 500 kg Newton, 500 kg of load, this T2, obviously it has to be less than 500 kg, because this friction is supporting us, okay. This friction is supporting us. Now further, if I go here, this force F, okay, will be further less than that of this T2, because here also friction is there, and that friction is supporting me further. So this F2 has to be surely less than, that is F has to be less than T2, because this friction is supporting me to hold it, and this T2 has to be less than T1, because friction here is supporting me to hold it. That's it. So both the frictions are supporting me in order to, in order to hold that body. Okay, so this is one point which we need to understand, and once if I do that, the problem is almost done. So T1 is 5000 Newton, and T2 is not known, which is equal to E into mu is 0.2, and the theta is pi by 2. Okay, solve this and get me the answer, T2. Anyone? Just give me the answer here. So it is 5000 by 1.37. Okay, 5000 by 1.37 value. Anyone just give me the answer. Okay, I will just give you the answer then. 3, no, it is very big. Yeah, 3652 is fine. Yeah, 3652 is fine. Okay, so this is our T2. Okay, now I need to find out F, right? Because I don't want the T2, I want to find out F. So how can I proceed further? Again, I need to draw the free body diagram for capstan. Fine. So this is my capstan, and they said very clearly that we are twisting it 2 times. Okay, we are twisting it 2 times, and then I'm holding it here. Okay, I'm twisting it 2 times and I'm holding it here. Okay, so this is tension T2. So this is how my free body diagram looks. Very simple free body diagram. But as I'm twisting it 2 times, okay, what will be my angle? What's going to be my angle theta? See here, 90 degree. Angle of wrap was 90 degree. Angle of wrap is 90 degree. But when it comes to this case, angle is going to be 2 pi. Because not 2 pi. I'm twisting it 2 times, right? So 2 into 2 pi. 2 into 360 degree, which is nothing but 720 degree. 2 into 2 pi, that is 4 pi. Okay, 4 pi radian. I'm twisting it 2 times, which has been given to us in the question. Okay, wrapped it twice. Okay, it is wrapped twice. So theta is 720. And again, as usual, which one is going to be tight side and which one is going to be slack side? In this case, this is slack. Okay, this is slack because F is lesser. Okay, F is lesser than T2 and T2 is going to be tighter. Okay, so it is like T2 by F will be equal to e to the power of mu is how much, 0.2 into theta is 4 pi. Okay, I don't know what happened to this. Yeah, fine. So from this, F will be equal to T2 by e to the power of 0.2 into 4 pi. Anyone calculate it and give me the answer. T2 is nothing but 3652 by e to the power of 0.2 into 4 pi. 295 point, yeah, fine, 295. Yes, super, 295.8. So F is 295.8. Now you can easily understand this, right? We are lifting a load. Okay, we are lifting a load which is 5000 Newton. Not lifting, we are holding. Okay, we are holding a load of 5000 Newton, okay, with the help of just 295 Newton of force. How I could do this? Because of the friction between barrel and this rope, and also friction between capstan and the rope. Okay, but there is going to be a twist when I try to lift it. Okay, there is going to be a huge twist when I try to lift it. See, what is the special nature of the friction? Friction is going to always act in the opposite direction as that of the relative motion. Okay, friction is going to always act in the opposite direction of the relative motion. Now, just imagine, I hope the second case is clear, right? First case is nothing. Okay, first case is nothing if you don't apply the force, or if the force is lesser than this 295 kilonewton. Okay, if the force is lesser than this 295 kilonewton, it's going to move down. Okay, but now the problem here is, third case means what? I have to move it, right? I will just erase it. Okay, let it be. Yeah. What is your doubt, Nanda? What's your doubt?
Sir, can we use F is equal to 500 into 0.56, 0.6?
0.6.
Yes, sir. There are two times we are rolling, so 0.4, and one time in the barrel 0.2, 0.6 total. The total load 500 is equal to force divided by 0.6. Then the force will be 294.
No. You should not do like that. See, that is not correct. No. That is not correct. See here, here you are rolling it two times, so that is why you are getting the angle as 720 degree. But here it is like 1/4 only, right? What is that here? Here it is just 1/4 only. 90 degree means you are rolling it. That is, you are wrapping it by 1/4 only. So directly 5000 by 0.6 is not correct. It's not correct. Okay, let me come back for this. I hope it is clear. The 5000 by 6 is not correct. It's completely wrong. You need to go with this formula only. T1 by T2 is equal to e to the power of mu theta. Yeah. Okay. So the problem here is when I try to lift it up. Okay, when I try to lift it up, when I try to hold it at the position, friction supported me. Okay, that is very obvious. Friction supported me. When I try to lift it up, friction is going to oppose my force. I hope you are getting my point, right? So if I try to lift this load, okay, if I try to lift this load, obviously I need to apply a tension. I need to apply a tension which has to overcome this weight, and also it has to overcome the friction, because now it has to move. Now it has to move in this direction. Okay, and also this force, the force which I'm applying, it has to overcome this tension and also this friction. It has to overcome the tension and also the friction. So when I try to move up, okay, when this body has to move up with some acceleration, okay, it has to move up with some acceleration, then obviously this tension which I'm applying has to be greater than that of this tension. So which means in our case 3, this will be my T1 and this will be my T2. Okay, so when this is true, when load is moving up, okay, when load is moving up. Why? Because T1, that is the tension which I'm applying in this string, not only it is going to lift this load, it is also going to overcome the friction. That is a speciality of friction. Sometimes friction will be positive for us, sometimes it's going to be negative. If I want to hold this load at the same position, then the friction is helping us. But if I try to lift this body up, the friction is going to oppose this. Okay, so in this case, T1 will be greater than T, that is T1 will be greater than T2. This will be my T1. So T1 by T2 is 5000, right? T2 is 5000. So T2 is 5000, which is equal to e to the power of mu, which is 0.2, and theta, which is pi by 2. And from this, I will find out T1. Okay. And now I will just leave it for you guys to solve it. Okay. And now, what about capstan? That is, what about the force I need to apply? F is going to be greater than that of T2. Okay, F has to be greater than that of T2. So this is case 3. Okay, that is when the body is moving up. Okay, I have given you load is moving up. Okay, when the load is moving up. So F by T2 will be equal to e to the power of mu theta. So which is nothing but e to the power of mu is 0.2 and theta is 4 pi. And F by T2, I'm sorry, T1. I'm very sorry. T1. This is T1, right? In this case, this is T1, this is T2. Yeah. So T1, this is T1. So T1, I have not calculated it. No problem. So take this and substitute it here. F is equal to e to the power of 0.2 and theta is 4 pi into T1. You will get F. And this F is going to be much, much, much greater than that of the load which I applied. What is the answer? Just calculate it and get it. Okay, so ultimately what I was supposed to say, same question. Okay, same question they can twist. Okay, same question they can twist. If suppose in the same question they are saying that load is moving up, okay, load is moving up, then the problem will be this friction is not only going to, that is, this friction is going to oppose the applied load. Okay, I'm trying to move this what is that, rope left to right. As I'm trying to move this rope left to right, the friction will try to oppose it. Okay, the friction will try to oppose it. Similarly, I will try to move this rope left to right, and this friction will try to oppose it. Okay, so this force F has to be greater than this T1, and this force T1 has to be greater than that of T2.